Boys and girls, welcome to our session on floating and sinking. This is Form 4, okay? This is a lesson in Form 4. So I can write here, Form 4, okay? So, many times when you are in primary, you wonder, how come a needle or a nail can sink, but a big metallic ship floats? Okay? And in primary you are told it's because of the shape. Now at that level, you can accommodate the shape, but it is more than the shape. It is more than the shape. There are other factors that come into play. Let us look at a simple experiment from which we will be able to reason and maybe come up with a genuine reason as to why we have these scenarios of sinking and floating. In the lab, we can carry out a simple experiment to verify a few facts. Let us look at the board. Okay? You can do it at home if you have some weighing machine. Okay? The first thing we need to do is to weigh the object in air, the weight in air. So we can write this as weight in air. Okay? You can do that. You can get the weight of an object like this in air and note its weight as W1. Okay? And then you need to weigh a beaker or a container which will collect water displaced. Okay? You can have even these bottles cut off the upper part. Then you have half of it. You can weigh that and it will be weight of empty beaker. In your case, that plastic bottle will still do the same work. Cut it half and then you have it. From there, you must prepare a Eureka can. A Eureka can is a collection bottle with a spout that will release water above a particular level. You may have seen a device like this, a container like that. Okay? It has where water can come out. And already we have the weight of the beaker or a kind of plastic container which can collect water. So, our focus is on object, this object. That is the main focus. And then, what has been collected, you can see here, I have used these kind of lines, and here I have crossed them, just to give you a picture that this is different from that, as we shall see. Okay? So, weigh an object like a stone, a small stone in air. Whatever the spring reading is, give it W1. Okay? After that, you weigh a container that will be collecting water displaced. That weight, call it W3. Now we carry out our experiment. is partially immersed. So you will read its weight W2 up here. Remember, W2 is the weight of this object when it is partially immersed. Okay? I've stressed here object. Then you can have the weight of the water displaced and the container weight. You can have this water that has been collected, which is inside a beaker, that you know its weight. So you weigh now the beaker and the collected or this water displaced. Give it 4. Weight of beaker plus displaced water when it is partially, the object is partially immersed. You must go step by step. When it is partially immersed, you collected some water into the beaker whose weight is known. Now you take again and give it W4. You can see the beaker and water displaced when the object is partially immersed. Give it W4. Then you come here. Immerse the object completely in the water. Completely in the water. The Eureka can will allow some water to come out and collected in a beaker that you had weighed. So you know the weight of the beaker, and now you have some additional water. Which additional water? You can see I've tried to give it a difference between this and that. That this water displaced is due to total immersion of the object. The weight of this object, when it is inside the water, we read it there. We can read it here. Okay? We can read it there. Straight on the spring balance. Remember, we are focusing on the object and the water displaced. The weight inside the water of this object, when it is totally inside the water, can be read. The weight of this object, when it is partially inside the water, you can see part of it is out, can be read directly. So, try to get the steps. We have to know the weight of the object partially immersed and when it is completely immersed. Then we take the weight of water displaced. Weight of water displaced plus the beaker when the object is partially immersed and when it is totally immersed. So you come here, weight of object totally immersed is W5 here. W5. This. Okay? Weight of object when totally immersed, we can read it here. We give it W5. Okay? And then we can talk of weight of beaker plus displaced water. Now we are talking about weight of this. Okay? You can give it number 6. You can see 6. Now we are talking about weight of the beaker and the water that has gone in. Here. Weight of beaker plus displaced water. Water displaced is W6. Weight of this object is here, W5. 5. So the weight of this object you read on the spring. The weight of this part and that part requires some calculation because we have the weight of the beaker, empty beaker. So this is basically what you need to do. When you are at home, you can do this. There will be slight variation of the correct figure, maybe arising from your measuring device, weight measuring device. That is the only problem we may have here. So let us look at some of the calculations. We want to find out a few things. Number 1, okay? Let us deal with when the object is partially immersed. Here. We want to see this W2, which you are reading for the object, and this displaced water. Is there any relationship? Get weight, loss in weight, loss in weight. When a body is inside the water, it appears to be in bracket or in quotes, light. It appears to be light. But the object is the same. This object is the same. But here it appears to be light. That is what leads us to say apparent loss in weight. Apparent. When we talk of apparent, is something not real. Apparent loss in weight. Because it was W1 and now it is W2. So we take W1 minus W2. So we have compared weight in air and weight in water when the object is partially immersed. Okay? So we get the reading of the springs and subtract 0. But when we want to get this water here, this water inside here, and we know the weight of the empty beaker, so we shall get the total weight here minus the weight of the empty beaker, which is here. If I want to know weight of water displaced under which scenario? Partially immersed. I will take weight of the beaker plus weight of water displaced, which is W4. I weigh both the beaker and the water. This is W4. Everything here. Beaker plus water. And then I will subtract the weight of the beaker, which I have shown you here. This is beaker. This W4 stands for beaker and water partially immersed. Beaker and water partially immersed. This is the scenario, this. Then subtract the beaker. I'm just using this to help you, even in algebra. B will subtract B. So we will remain with only weight of the water when object is partially immersed. Yes. Okay? That is the scenario when object is partially immersed. And you find that W1 minus W2 equal to that. Okay? Let us look at totally immersed. Total. Here. This object is now totally immersed. Totally. Then we collected some water, which I have shown you differently. So this scenario is I have the beaker plus water, under which situation totally immersed. Okay. So number 1, what is the apparent loss in weight? Apparent loss in weight always is weight in air minus weight in that particular scenario. So I have weight in air, subtract what is shown on this spring. There are spring subtractions. Spring subtractions. Apparent loss in weight in this scenario. You can see this minus that. In my second case, it is this minus that. Spring readings. That is one. Part 2. How can I get the amount and consequently the weight of water displaced? So I have W6, this scenario, minus this empty beaker. W6 minus W3. What is W6? It is beaker plus displaced water. Under which situation? Total immersion. Totally immersed. Here, PI, partially immersed. TI, totally immersed. Even if I was to use algebra, B plus water minus B. B will cancel minus B. So you have weight of water under which scenario? When it is totally immersed. So this work is attributed to Archimedes. Hence, Archimedes Principle. So when a body is partially or totally immersed, there appear to be some upward push. When a body is partially or totally immersed, there seems to be the difference in their weight. This difference in their weight is what Archimedes studied. So we can say here weight 5. Okay? What we are reading on the springs is what I've given as W1, W2, W5 in red. The springs. So when it is in air or partially immersed or totally immersed, the readings are not the same, yet the object is the same. So we say there appear to be another force somewhere, such that when you add to this, you get that. When you add to this, you get that. That is what we call upward force or buoyant force or upthrust. There seems to be something pushing. Okay, that what is pushing is what we call upthrust. So Archimedes summarized, when a body is partially or wholly immersed, so when a body is partially or wholly immersed in fluid, it experiences upthrust, which is equal to displaced weight of displaced fluid. Weight of displaced fluid. I've used fluid because we have to deal with also air. It is the same, it will be applicable. Okay? The weight of the amount of air or liquid that has gone away so that the object can occupy that space gives you upthrust. Okay? So this is a simple experiment that you can do at home. And from this, you can conclude these two are equal. This and that are equal. Also, this and that are equal. Folks, this can be done at home. You need to just get the procedure. Weigh a particular object you want to use. Weigh a container that will be collecting water, in our case at home, water. Then you must have a spring balance. The spring balance, maybe with a thread, so that you can weigh these things at home. You can do it. Don't stay idle. After that, remember, focus is on what? Object and the amount of water it will displace. That is the focus. And you have to move systematically. You get the weight in air, weight when partially immersed, then weight of the water displaced when object is partially immersed. Then you come to weight when totally immersed and weight of water displaced when the object is totally immersed. From those, you can get apparent loss in weight. Why is it appearing lighter? Why is it appearing lighter in water? You get W1 minus the W's when partially immersed and when totally immersed. Then you can compare with the weights of the water displaced. After that, you can conclude there is an upthrust. So even the ship experience upthrust. But we shall study more and see the law of flotation. Till then, subscribe. You'll get something small, either in Form 1, in Form 2, in Form 3, in Form 4. Please work hard. You never know what will happen next. Bye-bye.